when you ask any C# developer that what will you do if you want to generate a random number using C#, the first thing he will point you out is this random class. This random class belongs to the system namespace. So a lot of C# guys, the first thing when you say that you want to generate a random number, they go and they create an object of this random, and then you can say here console.writeLine and say obj.generate a random number, right? So this goes and generates some random number for you. But let me tell you that this is very, very basic. This is very, very basic. Basically, when you say that you want to generate a random number, you have to give a lot of thought around it. So in order to streamline this thought of randomness, let us first try to understand the English meaning of randomness, or how does the phenomena of randomness actually occur. Randomness means that something which happens undeterministically, something which you cannot predict, is termed as randomness. Means, for example, I tell a person that, okay, these are number from 1 to 10, choose what you like. He can sometimes choose 8, he can probably choose 1, or he can probably choose 4. So what he chooses is something I cannot predict, is termed as randomness. But now let us go more in depth into the phenomena of randomness. But now if you really visualize internally this process of randomness in more detail, you will come to a conclusion that randomness is also very well thought. It is very well planned actually. So randomness is not really random. Means what? For example, if I tell a person to choose between 1 to 10, that initial thought which goes in that person's mind that he wants to choose 10 or he wants to choose 1, is that triggers that randomness. Means, for example, let us say the person is a person who always wants to stand first in his life, right? So he will choose 1. Or let us say the person is a person who wants to actually always take big figures, so he will choose 10. So basically, even this randomness has an initial thought, an initial event, an initial trigger which actually forces him to choose that random thing. This initial source, this initial event, this initial thought which triggers the randomness is termed as a seed. So in other words, if a person knows what is the seed, he can predict the randomness. Means, for example, if I know that the person likes big numbers, so when I tell him that you choose 1 to 10, I know that he will choose 10 because I know his initial thought. So that means that if you say that something has to be random and unpredictable, then this seed has to be unpredictable. If the seed is predictable, then even the random number is predictable. So now let me classify a randomness into 2 sections or into 2 categories. One category of random we can say pseudo-random. The other category of random we can say secure random. Pseudo-random means the initial seed of pseudo-random is very predictable. For example, I'll tell you, this random function, this random class uses your CPU clock as an initial seed. So it goes to the CPU clock, it goes to your clock's date and time, uses that and generates a random number. Now a clock date and time is very easy to predict. I can use that and I can think that how he is predicting the random number. So a pseudo random number has a seed which is predictable, which can be judged. A secure random number's initial seed is very, very difficult to predict. For example, there are some random numbers which are generated depending on the noise, depending on the keyboard of the computer, how much time the keyboard is pressed, depending on something else. So basically these kind of inputs are very, very difficult to predict, right? So basically you can categorize random numbers into 2 categories. One is a pseudo random wherein if a person wants, he can predict your random number, he can predict your randomness. And the second one is where it is very, very difficult to predict the randomness, and that is the secure random numbers. Now this random class here, if you go and see in the tooltip, it says that if you go and move your mouse here, or I can say if I see to a next, or okay, if I move my tooltip over here, you can see it says that it represents a pseudo random number. Can you see that? Look at that word, pseudo random number. So pseudo random number means that this class generates random number from a seed which can be predicted. But now both of these random categories are useful as per business scenarios. For example, if you say you want to generate random test data, so at that time, security is not important. It is okay if people can predict your test data, right? So in that case, this random class is wonderful. But now if you say that you want to use a random number for cryptography, or if you want to use a random number for security, then at that time you want that it should not be predictable. For example, if you're making a poker game, then you want the randomness to be really, really random, isn't it? So basically, if there is very basic use, like generating test data or just generating a number randomly, then I think this random function is good. Okay, so let me go and let me create a class, just encapsulate this into a method. So I'll say get pseudo random. Okay, so I'll just say return. So what I've done is I've just taken that the random object and put it into a class, and let me convert it into a string. Okay, so the next function actually is an integer. So now if you see here, so let me do a console.writeLine. So let us say, okay, get pseudo random. So let me try to get pseudo random 3 or 4 times. Look at this. Now watch. Random numbers should not repeat himself, right? So when I say should not repeat himself means it's not about uniqueness. Okay, unique and random both are different. When I say random means it should sometimes take 10, it should sometimes takes 8, right? But you can see that it is not. You can see that I called the get pseudo random 4 times and I'm getting the same number. Why is that? Because this random class takes the seed from your clock time. So until the clock time does not change, this random number will not change. So that means what I should do is I should not create the random object again and again. Remember, this seeding happens over here. So what I should do is I should actually go and create the random object only once, like this, and then call the next again and again. So if you do that, then this next will actually ensure that he picks up a random number. So do not create the object again and again, because if you try to do that, then it is highly probable you will end up with the same number. But if you see now the output, if I do a Control F5 now, you can see that now I'm getting different values, right? So remember, first point to note, a random class in .NET generates pseudo random number. Pseudo random number means random numbers whose seed can be predicted. Why random class seed can be predicted? Because it takes the seed from the clock time, and clock time can be easily known, right? Second point to remember is that if you create the object of random again and again and call a next, you will probably end up into the same random number. So what you should do is you should first create an object of random and then call next and next again and again. So now the next question which can come to your mind is that so by default the seeding is happening from the CPU clock, isn't it? So next thing which will come to your mind is that can I go and override this seed? So is it possible that I can say, okay, don't use the CPU clock because it is very much predictable, let me generate a random seed and give it to you? So yes, again, that is possible. So in that case, what you can do is you can create the random object again and again, because now you have decided to create the seed. So you can go and you can give a seed here. So I'll say new random seed. So sometimes I can say, okay, 10, sometimes I can say it is 20, sometimes I can say it is 50, and sometimes I can say it is 100. So now what will happen is, because now you have said that you will give the seed and you are trying to give a very random seed, so he will actually go and generate a very random number, right? So if I now do a control F5, you can see that because the seeds are random, the random numbers are also random. So in other words, the basic thing for randomness is that how the seed is generated. If the seed is predictable, it becomes pseudo random. If the seed is very difficult to predict, then it becomes a secure random. And also you have some nice features here in this random class. For example, you can give a range here saying that I want to generate random number from 10 to 50, right? So with this, you would get random numbers within that range. You can see now the random number is repeated over here. Why is it repeated? Because it is taking from a CPU clock, right? And CPU clock, it is possible that it is having the same time, so that's why these two values are getting repeated here. But in case you want to give a range, you can always say it is between 10 to 50. So this random class is great. Actually, this random class is great if you want to generate a pseudo random number. But now what if you want to generate a secure random number, a random number whose seed cannot be predicted? But now what if you want to generate a random number whose seed cannot be predicted? In other words, you want to generate a random number which is secure. Let us say that you want to create a seed which uses the thermal temperature of the computer, which uses the noise of the computer, which uses the keyboard press of the computer. So basically it uses something which the human cannot even think about. So how do you do that in .NET? First thing, if you are brave enough, go and write your own class, right, to do that. Or second is use the .NET cryptography class. So in order to use the .NET cryptography random number, we need to do something like this. So I'll say this is get secure random. And what we need to do is we need to go and create the object of this RNGCryptoServiceProvider, and this class is available in system.security.cryptography. So let me take that, and I will return a random number which is of this size, and I need to go and say rng.getBytes, and then I get the random number, right? So you can see that if you want to generate a secure random number, you need to go and use the RNGCryptoServiceProvider. Now one thing which will come to your mind is that why is this random number put it into cryptography? Because it is a secure random number, right? So if I now go and call here get secure random number, you don't need a seed for this, because I'll tell you how the seed is generated. So place this. So now this secure random number input cannot be predicted. So if I do a control F5, you can see that it is generating random number very randomly, right? So one thing which you will question me now is that, so can you tell me that how the seed of the RNG crypto is generated? So is it from the clock? Is it from where? Actually, the seed of RNG crypto uses the operating system entropy, an English word whose meaning I did not understand some days back. Entropy means randomness. So what the operating system does, it has something called as the entropy. Entropy is nothing but basically it is a randomness given by an operating system, and using that entropy the cryptography creates his seed. For example, to generate an entropy, a randomness in operating system, he uses the mouse events, he uses when you type, the time taken for typing, he uses the acoustic sound. So he uses all of these to generate the initial seed. For example, think about it. If let us try to understand in a very basic way how the initial seed happens by using the mouse event. Okay, so you have a mouse event. Let us say, it has happened first time it has happened 1004 times, then it has happened 1012 times, and all that, right? So you can see these are the mouse events which have happened till now. So first thing what it does is it goes and it finds the difference between each one of these events of the mouse event category, and it finds 3 times or 4 times the difference, and after that he takes the least value, for example this 2, and he then makes a log out of it. So this is the way in Windows and Linux the entropy is calculated by using the mouse event. Now in the same way there can be other logic which will use the key press event time, even the sound, and so on, right? So you can see if the seed is generated from this natural things, it is very, very difficult for a human to predict the initial seed. If you look at the random class, it was very easy to predict the seed because it was the clock time, and humans know how to see a clock time. But now here it is very difficult for a human to really measure the mouse event, their timings, then do a log of it, and then the sound. It is very, very difficult, isn't it? So basically this RNG cryptography service provider uses the operating system entropy to calculate the seed, and that's why this random number which is generated from RNG cryptography is secure. It is very difficult for a common person to predict the random number. Also, one thing which I would like to point here is that generating pseudo random numbers are very faster as compared to secure random numbers, because secure random number use that OS entropy, which is definitely very complex, while pseudo random number uses a very simple seed calculation. So remember that from the performance aspect, pseudo random numbers are very fast generated as compared to RNG crypto or secure random numbers. Also, I'd like to bring to everyone's notice here the difference between random and unique. A lot of times I've seen developers, they get confused with random and unique. Random means that you have set of things, like you have 1 to 10 number, or you have A to Z alphabet, and from that you want to select unpredictably. While unique means that a unique value, which will not repeat again for that instance. Okay, so remember that a lot of people, they get confused with random and unique. If you want to generate unique values, then you need to go and use the GUID. Okay, the GUID class of .NET actually helps you to generate a globally unique identifier number, which is of 32 characters, and which is actually unique in time and space. So you can go and say GUID.new GUID, and you can say control.writeLine and str. So this will generate unique value, and this unique value will be unique in time and space, means it will never repeat again. You can see that over here when these unique values are generated, it also has dashes in between. So if you don't want the dash, you can say here .toString, I just want the number, right? So in that case you will just get the value without the dash. Normally the GUID also has braces, so if you just say that okay, you want with a brace, right? So now you can get with the braces as well as with the dash. So remember, if you want to generate unique values, use GUID. If you want to generate pseudo random numbers, use random. And if you want to generate secure random numbers, use the RNG crypto. So next time when you say that you want to generate a random number, first thing what you need to think about is that, so do you want it pseudo, do you want it secure, or do you want it unique? So I hope that you enjoyed this video. In this video we were trying to understand the different concepts around generating random and unique values through C#. Thank you so much.